Hello, today we're going to look at a few more examples of right triangle trigonometry. And as we already talked about, these are the trig functions. Another way to think about this or to remember is so, ka, toa, where so stands for sine is equal to opposite over hypotenuse. Cosine, C, ka, is equal to adjacent over hypotenuse. And toa is equal to tangent over adjacent. And this only applies to right triangles. Okay, so again, this only applies to right triangle. Let's find this missing angle. So we have angle A, and we want to use what we have. So we know we have this angle A, and what do we have? We have the hypotenuse, and we have the adjacent. Well, the adjacent and the hypotenuse is cosine. So we know that we can use cosine of theta is equal to 12 over 13. And so remember to have your calculator in degrees, because I'm finding out degrees, not radians. Cosine inverse of 12 over 13. And we're just going to type that into our calculator. So that's cosine inverse of 12 divided by 13. And that gives me 22.62. I feel compelled to show you how to put it in your calculator. So let's do that. So here's our free graphing calculator at desmos.com. I'm going to come here and I'm going to go to this button here for functions and I'm going to click on cosine inverse. Then I'm going to do 12 divided by 13 and notice I didn't get the same answer. I bet you know why, because this is not in degrees. So I'm going to go over here to my settings and I am going to see it's clicked on radians. I'm going to click on degrees. And now I have the same answer of 22.62 degrees. Okay. So now let's do another one. All right, so again, we're finding this angle and we need to look at what we have. What do we have? Well, we have the opposite side and we have the adjacent side. So the function that can give us that is tangent. So tangent of our angle is equal to the opposite, which is 7.7 over 14. And oops, we'll put in tan inverse of 7.7 over 14 in our calculator. And I get 28.81. degrees. All right, now we want to find a side. So how do we find this side? We're going to use the exact same things that we've been using, right? So we have the hypotenuse, who's right across from the right angle, and then I have the adjacent. So hypotenuse and adjacent is cosine. So I know that the cosine of 60 is equal to x over 11. And now I'm just going to solve. So the way to solve, I multiply both sides by 11. And I get 11 times cosine 60 should give me my x value. So let's put that in our calculator. And I get 5.5. All right, so x is equal to 5.5. Oops, x equals x. All right. Now we were tasked with something a little different. So they want us to find secant of our theta. We have all of our sides here. And so if you recall, secant theta, is equal to 1 over cosine theta. So how about we just find cosine theta first? I think that's a good idea. So here I have my theta, And cosine, if you recall, is adjacent over hypotenuse. So the adjacent side is 10 root 2. And the hypotenuse is right across is 15. So if I want to flip this, secant, so I can have my reciprocal, it's going to give me 15 over 10 root 2. I can't leave that root 2 down there, remember? So I'm going to multiply the top and the bottom by 2, root 2, excuse me, to get rid of that root 2. So I get 15 root 2. Root 2 times root 2 is just 2, so that's going to give me 20. Still have to always reduce, so that's going to give me 3 root 2 over 4. All right, here's another one. It says find sine of theta if secant theta is equal to 5 over 3. So this time we don't have everything, so I'm going to draw a triangle out. Do you have to draw a triangle out? Absolutely not. It just helps me to visualize. So secant is equal to 5 over 3. And if you recall, secant is just the inverse of cosine. So that really means that I have the hypotenuse over the adjacent side. So let's draw that on our triangle here. So my hypotenuse is 5. And sorry, this is my angle that I'm looking at. And the adjacent is 3. So now I can easily find out what this opposite side is, because I need opposite for sine. Because this is a right triangle, I know I can use Pythagorean Theorem. So Pythagorean Theorem says that leg squared plus leg squared is equal to the hypotenuse squared. So I have a squared plus 3 squared is equal to 5 squared. So a squared plus 9 is equal to 25. So a squared, 9 minus 25 is 16. I need to find out what a is. Take the square root of both sides and I get plus or minus 4. However, we're dealing with a triangle on length, so it can't be minus 4, so it has to be positive 4. So my other side is 4. So now I can find sine of my angle, which is going to give me the opposite, which is 4, over the hypotenuse, which is 5. So sine of theta is 4 over 5. And I hope that this helps.